Hi students, let us solve one practice paper 2023 for coming mains exam. The first question is, what are the functional groups present in the structure of maltose? Let us see the structure of maltose first. This is the cyclic structure of maltose. And here in this, H is present at the top, OH is at bottom. Here also OH is at bottom, then H is here, then here H, OH, and here ether linkage is there. Then here H, CH2OH, H. Coming to the first ring, here H will come, OH, H, and here H, OH, H, CH2OH, and whereas here H and this OH is present. If we observe this, we can see that ether and acetyl linkage is present here. So this is called as acetal linkage. Right? That means two ether groups are present. Whereas coming to here, ether and alcohol both are present on the same carbon. This is called as hemiacetal. Hemiacetal. That means in the structure of maltose, one acetal and one hemiacetal group is present. C is the answer. Next, coming to the second question, that is CaCl crystallizes in body-centered cubic lattice. If A is its edge length, then which of the following expression is correct? So in body-centered cubic lattice, generally oppositely charged ions touch each other along with their body diagonal. So in the case of this, Cs plus and Cl minus ions, these two are connected to each other. So the radius of cesium plus radius of chloride, which is equals to under root of 3 by 2 A. So this D is the answer for this question. Next, food preservatives prevent spoilage of food due to microbial growth. The most commonly used preservatives are table salt, sugar, yes, this is used as a preservative, vegetable oils and sodium benzoate, this is also used, sodium benzoate, this is also used, all the above. So all the above is correct. Next, coming to the fourth one, that is, which of the following statement is not true about classical smog? Right. So classical smog, let us, if you see the options, it contains compounds of reducing nature. Yes, this is correct statement. It is produced in cold and humid climate. This is also right, but we have to select the wrong statement, right? Its main components are produced by the action of sunlight and emission of automobiles and factories. So this is not true regarding what a classical smog. It contains smoke, fog and sulfur dioxide. This is also correct. Actually, classical smog is formed when there is high concentration of sulfur dioxide and particulate matter is produced. This is generally due to combustion of fuels. So that is the reason. So option C is correct for this. Next, fifth one. The number of aldol reactions that occur in given transformation is acetaldehyde when reacts with 4 moles of formaldehyde in the presence of concentrated NaOH will get this product. So here he is asking the number of aldol reactions. First, let us see the reactions of this compound. in the form of mechanism we'll discuss. Given reaction is CH3CHO acetaldehyde when reacts with 4 moles of formaldehyde, right, in the presence of strong base, that is OH minus, we got this compound. Let us see how this compound is formed and how many aldol products are formed in this reaction. Let us see. First formaldehyde I am taking. Which is reacting with the carbon ion of acetaldehyde, so that it will attack on carbon, double bond to oxygen, HC. In the same time H plus is added, so that O minus becomes OH, direct I'm writing CH2 CHO. Again here minus H plus takes place in the presence of concentrated base, that is sodium hydroxide. From this carbon, hydrogen is removed, so that we'll get OH, CH, CHO, here negative charge. This reacts with another mole of acetaldehyde. Then we'll get this product, HC. Of course, H plus is added here. CHOH, then CH, CHO, and this CH2OH is present. Right, CH2OH is present. From here, again, removal of hydrogen takes place from this carbon in the presence of a base, so that we'll get HC, HOH, C, CH2OH, CHO, here negative charge. This again reacts with the formaldehyde like this. In the presence of H plus, we'll get compound that is CH2OH, C, CH2OH, CHO, and here CH2OH. So this is a compound, right? Now this, in the presence of, right, base, strong base, that is concentrated NaOH, reacts with formaldehyde, reacts with formaldehyde, HCHO. See here, there is no alpha hydrogens. So in this compound, no alpha hydrogens present. That's why directly it is reacting with the acetaldehyde and forms, formaldehyde, and it forms CH2OH, 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 CH2OH. So total how many products are involved in this transformations? Let us see. Here one formaldehyde, the second one is involved here, second, right, and the next third. So total 3 are involved. So the answer is what? C. Next. Question number 6. Burette test is not given by proteins, carbohydrates, polypeptides, urea. Carbohydrates. Why? Because in carbohydrates, CONH2 group is absent. Generally, Burette test is used to identify the amide groups. Right. So in this, no CONH group is present. That's why carbohydrates are not giving Burette test. Among the following, the most basic compound is So all our amines are given. We know that acidic strength, basic strength, how it changes in the presence of electron withdrawing and what you call donating groups. Here NO2, CHO both are electron withdrawing groups. In the presence of that electron withdrawing groups, what happens? Basic strength decreases. Basic strength decreases. Electron withdrawing groups. So here in between A and B, B contains more number of NH2 groups. That's why this is more basic. Next, the compound form upon combustion of potassium metal in excess air is, yes, potassium when reacts with excess air will get potassium superoxide. KO2 is formed. B. Next, the number of donor sites in dimethyl glycinato, diethylene triamine and EDTA are. So in that is methyl glyoxime, the number of donor atoms are 2 and glycinato also 2. Diethylene triamine, 3 amine groups are there, so 3 donor atoms. EDTA contains 6. So 2, 2, 3, 6. The structures you have to know. So if you want, I'll write the structures of that compound. First one, what he said? Dimethyl glyoxinato, right? First one is dimethyl glyoxine. Its structure is CH3 and OH, here double bond. So 2 nitrogen atoms are present, so 2 donors. Next, coming to second one, that is what he said, glycinato. Its structure is, glycinato structure is O minus NH2. So here nitrogen will donate electrons to metal atom, oxygen is also donating. So here also we have 2. Here 2, here also 2. Next, coming to third one, that is, third one what they gave? Third one is diethylene triamine. Diethylene triamine. Right. So NH2, NH2. 3 amines are present. It will give electrons to metal. This is also given. This is also given. So total 3 are there. Next, fourth one is EDTA. Ethylene diamine tetraacetate, CH2, N, CH2CO minus, CH2CO minus, here also CH2CO minus. So 2 nitrogens are having 2 lone pairs. Here this oxygen is giving electrons to metal. This carboxylate, this carboxylate, even nitrogens also can give. So total how many? 1, 2, 3, 4, 5, 6. 6. So 2, 2, 3, 6. Next, the hybridization and oxidation state of oxygen atoms and hydrogen peroxide are respectively. Hydrogen peroxide is open book shape structure. each oxygen has 2 bond pairs, 2 pairs, so the hybridization is sp3, and oxidation state of oxygen in peroxides is -1, so -1, sp3 -1. C is the correct answer for this question. Next, coming to the question number 11. Match the catalyst given in the column 1, the correct process given in column 2, and select the correct options. So titanium chloride, general TiCl3 is the Ziegler's Natta polymerization which is used. Next, PdCl2. PdCl2 is generally used in the Walker's process. So in the Walker's process, what we'll use? Walker's process is used for the preparation of aldehydes. Generally, alkenes, that is terminal alkenes, are converted to aldehydes. Next, CuCl2. CuCl2 is used in which process? Decons process. Decons process is nothing but what? Preparation of chlorine. Next, oxidation of what you call hydrochloric acid into chlorine. V2O5 is a catalyst which is used in the conductor process. So A is 2, B is 1. A is 2, B is 1. So D option is correct. Next, question number 12. Oxidation state of nitrogen is correctly given for which of the compounds? Let us see. CONH3 taken 5Cl, Cl3. Here oxidation state of cobalt is +3. But here what is given? 0 is given. That is wrong. NH2OH minus. So here how I got +3? You know that ammonia is a 0 because it's a neutral ligand. Here -1. Here also -1. But 2 chlorines are there. -2, -1, -3, -3 becomes +3. So NH2OH minus, NH2 plus we can write. So here oxidation state of nitrogen, if you see, X plus 2 is equals to +1, then X is equals to +1 minus 2, then X is equals to what we will get? -1. But here they gave +1. That is also wrong. So you can say this is -1. Okay. Next, N2H5SO4. N2H5. Here oxidation state of this nitrogen is N2H5 plus you can write. So 2x plus 5, that is equals to +1. Then 2x is equals to -4. X is equals to -2. X is equals to what? -2. But here +2 is given. Next, Mg3N2. Mg3. So magnesium oxidation state is what? +2. So 3 into +2 plus 2x is equals to 0. Then 6 plus 2x is equals to 0. 2x is equals to what? -6. Then x is equals to -6 by 2, that is equals to -3. So this is the correct answer for the given question. Right. Next. So the answer is what? Answer is D. Next. Question number 13. In the solid state, PCl5 exists as. In solid state, PCl5 exists as PCl4 plus and PCl6 minus. C is the correct answer. Next, 14th one. For the reaction CO plus half O2 gives rise to CO2, the correct relation between Kp and Kc is. We know that the relation between Kp and Kc. Kp is equals to Kc into RT to the power delta n. If delta n is equals to 0, then Kp is equals to Kc. Delta n is greater than 0, then Kp is greater than Kc. Delta n is less than 0, then Kp is less than Kc. So here CO is gas, oxygen is a gas, CO2 is also gas. So let us see. Delta n is equals to, we have a formula. That formula is delta n is equals to number of gases products minus number of gases reactants. So gases products, how many are there? Delta n is equals to 1 minus gases reactants 1 plus 0.5, 1 by 2, that is nothing but 1.5, that is equals to minus 0.5. So this you can write as minus 1 by 2. So where minus 1 by 2 is there? In D option there is a minus 1 by 2 is present. So the answer is what? Fourth one. Next. Which of the following is not a method of concentration of metal ores? Gravity separation. Yes, it is a concentration method only. Froth flotation is also concentration. Electromagnetic is also concentration, but smelting is not a concentration method. Smelting is what it's a reducing of metal oxide to metal. Metal oxides are converted to metal. Right, is called as melting. So it is not a what concentration method. Next, coming to the question number 16. I need a place, that is the reason I erased that. Let us see 16th one. How to solve 16th one? The simple, here it's a problem. In this problem, what is asking? 1 liter of nitrogen and 7 by 8 liters of oxygen at the same temperature and pressure were mixed together. What is the relation between the masses of the two gases in the mixture? This we can get it from PV is equals to nRT formula. We want volume and number of moles. I'll take that only. Volume of nitrogen by volume of oxygen is equals to number of moles of nitrogen by number of moles of oxygen. We know the formula to find out number of moles. So number of moles, direct here I'll write volume of nitrogen by volume of oxygen is equals to mass of nitrogen by molar mass of nitrogen is how much? 28 into molar mass of oxygen is 32 by mass of oxygen. So volume is also given in the question. Substitute volume of nitrogen is how much? 1 liter. So 1 by 7 by 8, that is equals to mass of nitrogen by 28 into 32 by mass of oxygen. So here if you take the relation, mass of nitrogen is equals to mass of oxygen, you will get. C is the correct answer for this question. Next, which one of the following characteristic is not correct for physical adsorption? So here adsorption on solids is reversible. This is correct. Adsorption increases with increase in temperature. This is wrong. Right, is not correct is asking. B is not correct, whereas C and D are correct. Outermost electronic configuration of a group 13th element E is 4s2 4p1. The electronic configuration of an element of p black period 5 placed diagonally to the element E is simple. Here 4s2 4p1. So generally diagonal relationship is shown by what the two different period elements. So here 13th group element will show diagonal relationship with the 14th group element. For 14th group element, general electronic configuration is what? ns2, that is nothing but here 4s given, 5s2 it will come, 5s2 5p2 will come. So 5s2 5p2 is there with D only. Next, which of the following is wrong about molecularity of a reaction? So let us see. It may be whole number or a fractional. This is only wrong, right? Because molecularity never equals to fraction, 0, negative. It is always whole number. So remaining all are correct, that is B, C and D. Next, let us see the question number 20. The number of atoms present in one mole of an element is equals to Avogadro number. Which of the following element contains the greatest number of atoms? So it's simple. So we know the formula to find out number of atoms. Generally, number of atoms is equals to number of moles into Avogadro number. So Avogadro number is common, right? So just substitute this number of moles you find out, that's enough. 4 grams of helium, 4 by 4, that is equal to 1 only. Next, 46 grams of sodium, 46 by atomic weight of sodium is 23, that is equals to 2. 0.40 grams of calcium, 0.4 by 40 by 40, that is equals to 0.01, you'll get. 12 grams of helium, 12 by 4, that is equals 3. Maximum is there with what? D. Section B, numerical type of questions. 21st question. An acidic solution of dichromate is electrolyzed for 8 minutes. So here time is given, T is equals to 8 minutes. Current I is given 2 amperes. Next, reaction is also given. Then the amount of chromium obtained was 0.104 grams. Efficiency of the process is asking. Then the formula is Q is equals to I into T. Q is nothing but current, 2 into T is 8 minutes, 8 into 60, that is equals to 960 coulombs. Okay. So according to the reaction, here 6 electrons are participating in the reaction. That's why 6 into 96,000, right, will deposit 104 grams of chromium, because 2 moles of chromium, 1 chromium is 52. So 2 chromiums are there, no? So 104 grams will get. Then 960 coulombs. 960 coulombs deposit. What is the amount of chromium is asking. Then X is equals to what? 104 into 960 by 6 into, sorry, 6 is given in the question only, right? Grams. This is equals to 0.173 grams. Then let's see the amount of Cr3 plus obtained was 0.104 grams is given in the question, right? Then the efficiency is equals to actual weight by theoretical weight. Into 100. Okay, just substitute the values. Efficiency is equals to 0.104 by 0.173 into 100. So that is equals to 60%. Question number 22. So this is the estimation of phosphorus. To estimate the phosphorus, the formula is percentage of phosphorus is equals to atomic weight of phosphorus by molecular weight of compound. Compound is given Mg2 P2O7 into weight of compound formed by weight of organic compound into 100. This is the formula. So let us substitute the values. Atomic weight of phosphorus is 2 phosphorus are there. So 2 into 31 by molecular weight of Mg2P2O7 is 222 into weight of the compound formed in this is 1.332 by weight of the organic compound is 2.79 into 100. So if you simplify this, you will get 13.33 percentage. So the answer is 13.33 percentage. Next, 23rd. Consider the given reaction. So from that reaction, you have to find out X and Y values. Simple. Here, if you write the reaction, CH3 to this HBr is added, then you will get CH3Br here OH. So number of carbon atoms and the number of hydrogen atoms you have to find out. So here carbon atoms, if we consider 1, 2, 3, 4, 5, 6, 7. So X is equals to 7 and Y is equals to hydrogens. So here 1, 2, 3, 4, total number of hydrogens 8 plus 9, 10, 11, 12, 13. 13 hydrogens are present in the whole molecule. So here he is asking about X and Y is equals to how much? X is how much? 7 into 13, that is equals to 91. Next, 24th. So in this reaction, so when 2-butene is treated with bromine in presence of CCl4, we'll get 2 isomers. How many? 2 isomers are formed, and here anti-addition will take place in this reaction. So this is racemic mixture. 1, 2 isomers are possible. Right? Next, 25th. The number of chiral carbons present in the molecule given below is, here this is a chiral center, this is chiral, this is also chiral, this one and this. Total number of chiral centers how many? 5 chiral centers are present in the compound. Next, let's see 26th. The azimuthal quantum number for the valence electron of gallium ion is, gallium is 31. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p1. Ga plus is said, so one electron lost from here. Then valence electron is present in 4s. For s orbital, L value is 0. For s orbital, L is equals to 0. So answer is what? 0. Next, Ziegler-Nash catalyst. Formula is Al2 C2H5 6 plus tetrachlorotitanium. So substitute values in the formula. X is 2 plus Y is 6 minus Z is 4. So that is equals to 8 minus 4, 4. 4 is the answer. Next. The number of molecules among the following which do not satisfy the octet rule. BF3 will not satisfy, AlCl3 will not satisfy because they are electron deficient. H2O2 satisfies, H2SO4 also will not satisfy because it is superoctet. PCl5 also superoctet. Remaining all will satisfy. Okay. BF3 and AlCl3 is electron deficient. PCl5 and H2SO4 are electron rich, you can say superoctet. Superoctet state. Next. Question number 29. 20 degrees centigrade, the vapor pressure of benzene is 70 torr and that of methyl benzene is 20 torr. Mole fraction of benzene in the vapor pressure is 20 degrees centigrade above the equimolar mixture of benzene and methyl benzene is. So let us see. The formula used is, that is total pressure is equals to, we know the partial pressure of benzene which is multiplied with mole fraction of benzene plus partial pressure of toluene which is multiplied with the mole fraction of toluene. So the values are given in the question. 70 into 1 by 2 is the mole fraction because benzene and toluene are present, 2 atoms, 2 molecules, and here 20 into 1 by 2, that is equals to 45. Is it clear? Next, and here partial pressure of benzene is asking. Partial pressure of benzene is asking. So simply partial pressure of benzene is equals to, we have a formula that is total pressure which is multiplied with benzene. So from this mole fraction of benzene is equals to, we have formula that is total pressure, right? Total pressure, let's see, xb is equals to, you can write 70 into 1 by 2 by 45, that is equals to 35 by 45, so which is equals to 0.777, so 0.78 you can write. Okay, so that is equals to 78 into 10 to the power minus 2. 78 is the answer. Question number 30. One gram sample of octane is burned in excess of oxygen in a bomb calorimeter. Temperature of calorimeter rises from 294 Kelvin to 300 Kelvin. If heat capacity of calorimeter is 8 kilojoules per Kelvin, the energy of combustion of octane in kilojoules is. So simple here, delta T is given, that is 300 minus 294, that is equals to 6 kilojoules. Right? So heat given to the calorimeter is heat given to calorimeter is equals to heat capacity which is multiplied with delta T. So that is equals to, heat capacity is given in the question 8 into delta T is 6 we got, so that is equals to 48 kilojoules. 48 kilojoules. So as we know that molar mass of C8H18 is equals to 114. Is it here? This is required to calculate this. So 1 gram of octane gives 48 kilojoules of heat. Then 114 grams gives how much? That's it. So X is equals to 48 into 114. That is equals to 5472 kilojoule per mole. So the answer is what? 5472. Thank you.